We are going to start off our development of a 3D gaming engine by first of all understanding some of the mathematics. And this is best done by experiment. And we can do this using an online graphical calculator called Desmos. So if you get into Google and type in Desmos, you'll see the graphical calculator here. So you can click on this one and it'll bring up a graphical calculator. And this is us ready to start, and this is going to be our blank canvas for our initial developments. So what we want to do is make it a black screen. So you click on it on the right and you can change the reverse contrast, and then we've got a nice black screen to work with, and we can take out the grid and we're just left with our X and Y axis. We can add our equations in here. So I can get in and type, for example, y is equal to sine x, and we've got a nice little sine x function. But of course we're not wanting to do that, we're wanting to use the equations which we generated in the last video. So I've added in the equations here as a reminder. We have them in matrix form and also non-matrix form. Now this graphical calculator won't deal with it in matrix form, so we're going to have to type the equations in like this. So let's just crack on and we'll do that now. We have x1 is equal to x0 cos theta, and you can just simply type in x0 and cos theta and it will recognise it, minus y0 sine theta. So that's our first equation in. Now our second equation is y1 is equal to y0 cos theta. Now I suggest you type these in yourself and work along with me. Plus x 0 sine theta. So that's us got our equations typed in. Now we have the option here for creating a slider. So really what it's saying is x0 and y0 are going to be variables. So it's offering to create these variables. So you click on that all and it's now created the variable x0 and y0. In this instance here it ranges between minus 10 and 10. And right now it's got a value of 1. So we're happy to just leave it as a value of 1 for the moment. Now we've also got the input theta, but in order to get the theta we're going to have to give it a subscript, the same way we've done here. It's x0. So we'll call that theta and we can call it theta 0, 0, 0, and you can see it offers to create the slider here. But you can also go in and just type it in yourself. You can type in theta 0 is equal to, and just put any random value. So we'll just put a value of 1. So now what we want to be able to do is actually see the input and the output point. So in order to see the input point, you just create a point, x0, y0, and you can see it's generated that point, which will be the point 1, 1. And we'll keep the same colour there, and we'll get rid of that halo. So there we go. So that's our input point, x0, y0. But we also want to be able to see the output point. Well, output point is x1, y1. And that's it, generated that output point. Now we'll change the colour here, just for my preference. We'll make it pink. So that's ostensibly us built up the simulator here for rotating a point in 2D space. But I like to keep things a bit neat and tidy, so we can get in and create a folder. So we put in folder and we can call the folder equations, and we can drop our equations into the folder. So we'll put that one in and we'll put that one in as well. So that's that out of the way. We can create another folder and we can call it inputs. Now you don't always need to do this, but this is just one way I tend to work in order to keep things neat and tidy. So we've got x0 and our y0 are inputs, and also x0, y0 point as an input. So we'll close that, and we've got this simple inputs, and we've got equations, which is not spelt right, EQUA, equations, and the output here as well, a folder, and we'll call this one outputs, and we'll pop this in here. Okay, so we've got our inputs, outputs, and the equations that we're actually going to be using, and we've got our angle theta 0. So this angle theta 0 is in radians. So to go round the circle once in radians, it's going to go from 0 to 2 pi. So you just put in 2 and just type in pi and it will recognise the pi. So if we were to put this value at 0, it should sit on top of the input. So there you see it sits on top of the input because we're rotating it here by a value of 0 degrees, so it's not going anywhere. Now whenever I press play on this, you can click on this one here and you can click on this and it will continually work its way round in 360 degrees, and when it's went round once it will go round a second and third and fourth time. Now another useful thing to do here is if you click on this up here and click on lock viewport. So whenever you do this, it means that you can't zoom in and out here, and it kind of fixes it whenever you're working with the screen, which can be quite handy. So if I press play on this, you should see it rotating round about the blue point, and it will continually do it. So we've generated a rotation of a point in a 2D plane. So that's a start on our game engine. Not an amazing thing, but at least it's we have a tool that we can use in order to test out the mathematics. Now one other thing that we can do before we finish is, rather than working with radians here, a lot of people feel comfier and more happier working with degrees. So rather than going from 0 to 2 pi radians, they want to go from 0 to 360 degrees. So again, we can do a conversion here. So we could create the value theta 0, which will be in radians, and we can say it's equal to some value theta 1, which will be in degrees, and we've got to convert from theta 1, which is degrees, to radians. So we're going to have to multiply that by a value of pi and divide by 180. So this is going to give us a conversion from some theta 1, which we've not created, so we'll create it now, theta 1, and we'll just put some value in. So we've created the value theta 1, and it's going to be in degrees, so we can go from 0 to 360 degrees, and then it converts it into radians, theta 0, which puts it into the equation in radians. So if we get rid of this one here because we no longer need it, then we're going to have a conversion, and we'll take this here and we'll just stick in equations out the way. So now we're going to have the value here rotating from 0 round to 360 degrees rather than working with radians. And again, if you click on this and click on this one here, it will continually rotate round about. So that's us built a simple tool here that will allow us to rotate a point around another point in 2D space. Now, not particularly amazing, but as a start, and what we can do over the next few videos is we can extend on this, and rather than rotating in a 2D space, what we want to be able to do is rotate the point in a 3D space. So we'll work through that over the next few videos.